Good morning, sir. My name is E. Ravindra from Computer Science and Engineering, Section D. My roll number 23951A057H. Today, my topic in CSA is Introduction to Computer System Architecture. Computer system architecture is the conceptual design that defines the structure and behavior of a computer system. It encompasses the hardware components, their interactions, and the software that operates on them. Understanding architecture is key for optimizing performance and compatibility in computing. Here we can see in the diagram components of a computer system. Here we have a secondary storage device, primary memory, control unit, and the control unit have the input device and output device. And under the control unit we have the arithmetic logic unit ALU, central processing unit CPU. So all these components we have in the computer system architecture. So it means it shows the architecture, the building of the computer system. Then we have the components of a computer system. So in this, what are the components that the computer system architecture has? We can see a computer system is generally composed of hardware, software, and user interfaces. Hardware includes the physical components like the CPU, memory, and storage devices. Software refers to the operating systems and applications that run on the hardware. So here it says that the components which are the software and the hardware and user interfaces. Hardware systems are like the CPU and the keyboards and mouses like that, and the software system are like the programs, the code that we run on the run in the computer is called as software, and the interfaces is like kernel interface and user interfaces. So these are the components that the computer have. In the diagram we can see the all the components. We have the processor, memory, input and output, and the input devices, the storage device, and the output devices. So all these components are present in the computer system. So next we have the central processing unit CPU. So in this, the CPU, how does it works and what are the functions we can see here. The CPU is often referred to as the brain of the computer. It processes instructions from programs and performs calculations necessary for operations. So it operates and calculates the necessary programs to process any processes. The architecture of the CPU significantly affects overall system performance and efficiency. So the whole property of the computer system it depends on the CPU only. So here we can see the CPU, and its components. It has the system fan, floppy, heatsink, hard drive, optical drive, RAM modules, simplify, processors, CPU, motherboard, power supply. So the CPU contains all these components in it, and it works on works based on these components. So next we have the memory hierarchy. Memory hierarchy is a structured arrangement of storage types based on speed and volatility. So the memory hierarchy is a structure that is arranged to store the types based on the speed and volatility. It typically includes registers, cache, main memory, I mean RAM, and the secondary storage, HDD and SSD. So understanding memory hierarchy is crucial for optimizing data access and process speeds. So memory hierarchy is a structured arrangement which stores the types of data, that is the speed and volatility, and it includes the data stored in the memory hierarchy in registers, cache memory, and main memory, and the secondary storage devices. So this is memory hierarchy. And next we have the input and output devices. That means how does the input and output goes and how does the work in the computer system architecture. We see input devices allow user to provide data and control signals to the computer. Output devices present processed data to users, such as monitors and printers. The interaction between input and output device is essential for user experience and system functionality. So the interaction between the input and output devices is more efficient essential to work or process anything in the computer system architecture. So next we have the system interconnections. The system interconnections refer to the pathways through which data flows between components. So the system interaction is nothing but the pathways between the how the data flows from one component to another component. So back we have seen the components, and in that how the data is transferred from one system to or one component to another component. So these are the system interactions. Buses and channels facilitate communication between the CPU, memory and I/O devices. So here we have the buses and channels which are used as the transport managers or transport systems that exchange the memory or data from one component to another component. So effective interconnection design is vital for system performance and scalability. So the interconnection between the components should be very effective. Then the process will more, the performance will get more, and it works in a efficient manner. So here we can see in the diagram how to evolve upgrade a system. So there are two types: upgrade specification of the system, connect multiple systems together. So in the first one we have the 4 GB RAM i3 processor, 1 TB disk PCU, and it has the RAM upgrade, disk upgrade, processor upgrade. So in this we have the one CPU with multiple upgrades, and here we are connecting multiple computers together. So these are work as same, but we have the two types here. And next we have the storage systems. So where we store the data in this we can see. Storage systems are essential for data retention and retrieval in computer systems. They can be categorized as primary, I mean volatile, and secondary, non-volatile storage. The choice of storage technology affects data access, speed, and overall performance. So storage system technique technology affects the data access speed and overall performance. So here we have two types of data, that is volatile and non-volatile. The volatile is primary data which is volatile, that means if power will go, it will it will disappear. If non-volatile means it doesn't disappear even it is a power off or any other problem happen in the CPU systems or computer systems. So these are the storage systems. And next we have the instruction set architecture, ISA. So ISA defines the set of instructions that a CPU can execute and how they interact with memory. It serves as the interface between hardware and software, allowing programs to run on a specific architecture. Different ISAs can lead to variations in performance and programming complexity. So here we have the instruction set, that is first we have the instruction set architecture, and then we have the micro architecture, and then we have the registers and counters, and next we have at the last is combinational and sequential circuits. So these instruction set architecture gives the instructions to the CPU to execute any program with interacting with the memory. So different ISAs can lead to variations in performance and programming complexity. So that's why we have to use same type of instructions to run any program and not get any complexity problems in the programming. So next we have the system performance matrices. So performance matrices are essential for evaluating the efficiency of a computer system. Common metrics include through output, latency, and resource utilization. Analyzing these matrices helps in identifying bottlenecks and optimizing system performances. So it says that performance metrics are essential for evaluating the efficiency of a computer system. So analyzing these matrices helps in identifying bottlenecks and optimizing the system design the system performances. So here we can see in the diagram performance matrices. It has the people and it has some different matrices that the system will performance. And next we have the emerging trends in computer architecture. So the emerging trends include parallel processing, cloud computing, and energy efficient designs. These trends are shaping the future of computing, making systems more powerful and adaptable. Staying informed about these developments is crucial for professionals in the field. So here the emerging trends means the new methods or new upgrades that came in the computer architecture, that are like parallel processing, cloud computing, and energy efficient designs. These make the new computers more efficient and more performing, and they made more scalable to use them. So the types of computer architecture are: computer architecture can be classified into several categories such as von Neumann and Harvard architectures. Each type has its advantages and disadvantages depending on the application requirements. Understanding different architectures helps in selecting the right system for specific tasks. So there are two types of computer architectures. They are von Neumann and Harvard architectures. So these each type has its own advantages and disadvantages that use on the application, that you will use in the applications. So based on their advantages and disadvantages, we have to select which one we have to use in any applications. So understanding different architectures helps in selecting the right systems for specific tasks. So choosing the right one is the major problem, and here we can select by their advantages and disadvantages. So in the diagram we can see one human machine. First we have the memory data plus code, and in the between we have the CPU, and last we have IO devices. For from memory data to CPU we have the address and data, and from CPU to IO devices we can share data from both sides. And next we have the Harvard machine. So Harvard machine have two types, that is program memory and data memory. So both are connected to the CPU only, and from program memory we can share address only, and from data memory we can share variable addresses from both data memory and CPU also, exchange from one to one. But in program memory we can exchange from one single way, that is program memory to CPU only. So this is Harvard machine and this is one Neumann machine. So by our choice or by the problem of architect, by the given problem, we can choose which one is more sufficient or more efficient to use. We can choose in that. So next, the conclusion of this is computer system architecture is fundamental to understanding how computers work and interact. A grasp of its components and principles is essential for both hardware and software development. Continuous advancement in architecture will influence the future of technology and computing systems. So, the computer system is saying that the conclusion of this computer system architecture is it is a fundamental to understand how the computer works and interacts. So, continuous advancement in architecture will influence the future of technology and computing systems. So, the in nowadays both the computing system are growing very fastly, and they are getting more upgrades, and they are getting more updates, and they use them more efficiently. So this is all about the computer system architecture introduction, and I hope yes sir, so I hope this works good. Thank you sir, thank you for giving this opportunity to me.